Good day, everyone. I'm going to report under subject Advanced Design of Concrete Structure, the topic Diagonal Cracking of Concrete. By the way, I am Engineer Mary Apple Sanchez. So, first, we will discuss what is concrete and then what are the types of cracks in concrete, diagonal cracking of concrete beams. First, what is concrete? So, concrete is a composite materials composed of fine and coarse aggregate bonded together with a fluid cement that hardens over time. Concrete is the second most used substance in the world after water and is the most widely used in building materials. So, what are the types of cracks in concrete? The first type we have the shrinkage. Shrinkage cracks is in a poured concrete foundation can be diagonal or vertical, are usually uniform in width. Sometimes their cracks have a base shapes, with the top of the cracks looking larger and the crack getting smaller as it travels towards the floor and diminishing or stopping before reaching the bottom of the foundation wall. If the crack reaches the bottom, the crack might damage the building footings, and the crack might have a significant impact of the foundation structure. In poured concrete foundations, shrinkage cracks are usually due to conditions at original construction, poor concrete mix, rapid curing, or possibly other states. In any case, concrete shrinkage causes the concrete to develop internal stresses. So the second type is hairline. Hairline cracks may develop in concrete foundations as the concrete cures. Hairline cracks do not cause problems with the stability of the foundation, but do cause leakage problems. If the cracks appear shortly after pouring, the concrete concrete may have been mixed poorly or poured too quickly. In poured concrete foundations, hairline cracks frequently appear in the center of the walls because the walls' corners have greater stability. And the third type is the settlement. Settlement cracks may appear when the underlying ground has not been compacted or appropriately prepared, or if the subsoil was not of the proper consistency. A settlement crack may also appear as a random crack above areas where the soil of the subgrade was uneven after the concrete was poured. Settlement cracks are usually more extensive at the top of the cracks and the bottom as the foundation bends over the single point, allowing differential settlement. This type of cracks is usually continuous and may occur multiple times in a wall. So the fourth type is the temperature and shrinkage. Horizontal cracks found in the center of the wall are most likely caused by an applied load such as backfill around foundation, compacted improperly, or too soon. Earth compacting as it settles, hydrostatic pressure against the foundation due to high water table, and poor drainage against the foundation wall, or heavy equipment operated too soon or too close to the foundation wall. And the next type is the vertical. A vertical foundation crack due to earth loading or force would be unusual. A more massive vertical cracks can occur when the construction contractors incorrectly prepare the concrete footings and when the wall had poor steel reinforcement as the workers poured the concrete for the wall. Cracks can also occur during the footing settlement. So the next type is the horizontal. Horizontal cracks found in the center of the wall are most likely caused by an applied load such as backfill around foundation compacted improperly or too soon. Earth compacting as it settles, hydrostatic pressure against foundation due to high water table and for drainage against the foundation wall, or heavy equipment operated too soon or too close to the foundation wall. Horizontal cracks found high up on the wall are most likely caused by ferrous damage. And the next type is the structural. Structural cracks is residential foundation usually result from horizontal loading or settlement. Most, but not all, structural cracks resulting from an applied load or hydrostatic pressure or heavy equipment around foundation wall are nearly horizontal and applied 16 inches to 48 inches from the top of the wall, and they are common in block foundation walls. And the next type is floor. Floor cracks in concrete slabs are relatively common and unusual, not worrisome on the structural level. They should be repaired to prevent common issues like moisture, insect, and damage of the seeping through. When floor cracks leak, it is usually caused by hydrostatic pressure or high water table. Therefore, sealing of the crack will redirect those issues elsewhere. So fixing source of those problems beforehand is recommended. And last is the diagonal. Settlements usually causes diagonal cracks that are almost the full height of the foundation wall. When there's settlements problem, the footing on one side of the wall, these settlements can also cause a diagonal crack. So next is we will focus about the diagonal cracking of concrete beams. First, the cracks in beams due to increase in shear stress. So, cracks in concrete beams due to increase in shear stress appears near the support, such as wall or column. These cracks are also called a shear crack and are inclined at 45 degrees with the horizontal. These cracks in beams can be avoided by providing additional shear reinforcement near the support. When the shear stress is maximum at a distance of d over 2 from the support, where d is the effective depth of the beam. And the next is cracks due to increase in bending stress of the beam in the beam. Cracks due to increased bending stress in the beams appear near the center of span of the beam at an angle 45 degree with the horizontal. At the bending moment is maximum at that point. If the reinforcement provided is insufficient for the load to beam is exposed to, bending stress increases, which leads to increased deflection at the mid-span of the beam. Cracks due to increased bending moment can be prevented by providing adequate main reinforcement at the midspan of the beam. Care should be taken during the design of the beam. Consider all the probable loads and load combination for its design, and the reinforced section of the beam is the main cause of this crack. So last is the cracks due to compression failure in the beams. Cracks due to compression failure in the beams appear at the top of the beam is over-reinforced. In case of over-reinforced, the beam has the capacity to bear higher bending stress. But at the same time, if the top reinforcement provided is insufficient to carry the compressive stress, the top of the beam gets cracked. This type of failure can be prevented by designing a balanced section in which the capacity of the beam as compression is capable of carrying additional compressive stress. So that ends my report. Thank you for watching.